Good afternoon, everyone. Welcome to this first of our May on the Level webinar series, Exterior Air Barrier Details for the Northwest, Tried and True Construction Details for Integrating an Exterior Air Barrier into your home building process. My name is John Spillman. I'm trainer and senior technical consultant with Earth Advantage, and I'll be your host today for the webinar. Before we begin, I'd like to take a moment to thank our partners at Better Built Northwest for generously supporting this training. I'd like to start off by letting people know that this webinar is one of many training features provided as part of Earth Advantage's new Sustainable Homes Professional online course. And we welcome all the attendees of this webinar who have already signed up for SHP Online, along with everyone else who is joining us for today's webinar series. We'll be talking more about the Sustainable Homes Professional online training experience at the end of the session in case any of you are interested in this in-depth online training program. So I'd like to introduce our presenter today. Josh Salinger is founder and CEO of Birdsmouth Design-Build, which is located in Portland, Oregon. In 2007, he started Birdsmouth with the goal of designing and building beautiful, high-performing buildings that transform and improve the built environment. And Josh sits on the board of Passive House Northwest and is an Earth Advantage Sustainable Homes Professional, an EBA Zero Energy Professional, and Passive House Certified Builder. Birdsmouth, the company, has recently earned Earth Advantage Awards for Zero Energy Builder of the Year, as well as the lowest Energy Trust of Oregon EPS score of the year in 2018 and Earth Advantage Custom Builder of the Year in 2020. So Josh is going to be sharing some of the advanced air sealing techniques that he uses to show you how you can take your projects to the next level of air tightness and high performance. So thank you very much for joining us today, Josh. I'll go ahead and pass the screen over to you.
Okay, thank you, John. Appreciate that intro and welcome to everybody. Saw that we've got someone from Croatia joining us today, so thanks for the worldwide participation here. Very cool. No worries. Okay, so welcome everybody. I always like to start with this slide just because it kind of frames the importance of our industry in terms of our effect on the climate. So as you can see from this circle here, that orange section there is our buildings, and they do account for about 39% of the annual global greenhouse gas emissions on the planet. So if you're looking to make an impact on climate, our buildings actually are more impactful than industry and more impactful than transportation. So that's why we're here talking about this today. It's also, when you're starting to pay attention to the impact that the buildings have on the environment, it also turns out that it's a win-win-win situation where you also get buildings that are more healthy, they're more comfortable, more resilient, and have all these other great attributes to them too. So in terms of the slice, about 28% of it is the operational energy. So these are things like your plug loads and your appliances and your heating and cooling, all that kind of stuff. The other 11% is the embodied carbon into all the stuff that we put into our buildings. This slide is kind of scary, but it also, again, frames the importance of what we're talking about today. The global building stock is going to double in area by 2060. So you can see this chart's a little bit old, but if you take that line at 2018, you bring it over to the right, by the time we get to 2060, we're going to double. And so a city the size of New York City gets built once every 30 days on our planet. So that's the kind of impact that our buildings are having. So hopefully today we'll be able to talk about how we can save embodied carbon and also some of that operational carbon in our buildings. I'm going to start off here with some of the new energy code that's taken place in Oregon and in Washington. So there are some new air sealing requirements that came out just in April 1st of this year. So it requires a continuous air barrier to be installed and aligned with the building's thermal envelope on the vertical portions. Also, there are some specific requirements for air sealing at your top plates, sill plates, wall penetrations, rim band joists, shafts, all these different areas right here that's outlined in the code. And there's also this additional energy measure that is available to use, whereas if you can reach a 3 ACH 50 or less, you can get some points for that. Is also new with this new Oregon adopted code. Now, if you are going with the 3 ACH or less, you do have to have some heat recovery with a minimum sensible heat recovery efficiency on that. So here's some really good resources. Earth Advantage worked with NIA to create a fact sheet that gives you a quick summary of the major changes to the energy efficiency and the mechanical chapters of the 2021 ORSC. So definitely recommend you download a copy of this document. It's available on the Earth Advantage website if you want to check this out. We'll be sending out these slides also if you're interested afterwards, so you'll be able to get a lot of these links here too. Some additional resources here. The Building Codes Division has some video up that's great. I know I had our team go through this. And also the Oregon Home Builders Association has some live webinars. So please check these out to get more information on some of the Oregon code changes. In Washington, this was updated as of February of this year. They do it slightly differently up there. So there's changes to this table R406. You have to get 6 credits for your typical new home. And a lot of these credits, so up to 2 credits are available for air sealing and balanced ventilation. There is a 5 air changes per hour minimum requirement that's tested in Washington. So air sealing is going to become very critical up there. And I imagine with each consecutive code cycle, they're going to start taking that 5 down to 4 and 3 and so on and so forth. So really good to get ahead of this right now. Hopefully this webinar today will give you some good details and I can kind of impart some of the lessons learned that we've learned at Birdsmouth over to you to make this a little bit easier. Here's some good resources for the Washington Energy Code for those of you that are up there. So Better Built Northwest has some on-demand videos, and Washington State University's energy program also has some live and recorded webinars that you can check out. Also, if you can, go check out the Better Built Northwest website, and if you click on the Find a Professional button there, it'll lead you to some really good resources to help you find a certification program or an energy rater in your market. And so work with those people. They're there to help. They're there to, certify these buildings and make sure that, they're holding us to our word. So again, good resource with Better Built Northwest. Great. Okay, so like we just found out from our poll, it sounds like we've got a lot of people, savvy people on the webinar today. The biggest place that we're seeing the most air leakage in buildings is at the attic top plate to drywall. Really it's at transitions between building surfaces is where most of these leaks happen. So where one material meets another material, where walls and floors and roof lines meet, where there's empty spaces hidden behind drywall. So a common example of this would be behind maybe a built-in fireplace, or oftentimes behind a bathtub where the drywall just kind of ends and the bathtub gets bumped up against that, and there's a big source of air leakage there. Mechanical, electrical, and plumbing, that's the MEP, all those penetrations as we're putting those through our envelopes, big spots for air leakage. Bottom and top plates certainly, and windows and doors. So as you can see from that little chart on the bottom left, if you address the leakage at the attic top plate drywall, you can reduce your ACH 50 by 1.6 or more. So really impactful right there. The band joist or the rim joist at the bottom of the building or at the different floors of the building is the next biggest one. And then from there, we've got things like our duct boots at the HVAC systems to the finished surface, recessed lighting, garage house to common wall are the other big ones. So the Installation Institute put out this priority air sealing locations for new homes document. So this will be available on the slides too, if you want to dig a little bit deeper into this. So this slide right here is kind of showing that problem at the top and bottom plates. So these ugly pictures here On the left, you can see we kind of scooch some of that cellulose insulation away, and you can see where the drywall meets that top plate, there's a gap. And then the electricians come through and they run all their wires and stuff like that, also creating holes, which essentially just punches a hole in from the attic into the conditioned space. So, it's one of the biggest sources of air leakage. And if you take like a typical home, it has about 300 linear feet of top plates on it. And if you consider an 1/8 inch gap at that condition, it is about 3 square feet. And if you combine that with the leakage that you'd see at the bottom plate, it can be as much as having a window open 24/7 year round. So obviously, if you're trying to stay comfortable in your house and you're trying to sell comfortable houses to people, you wouldn't want to have a window wide open all the time. But that is in effect what's happening with the amount of air leakage that's happening at these locations. So just a great illustration to show how important this is. So how do you deal with it, right? Here are a number of solutions here that are common solutions. One is to use on the top there, you can see a sealant or a gasket at the bottom plate. Not necessarily sill seal. Sill seal is really meant to be a capillary break so you don't wick moisture from your foundation into your wood framing. It's not a great air barrier, but there are some products out there that are meant specifically for air sealing at the bottom plate. You can also, there's a bunch of great elastomeric sealants that you can use there too that don't dry up and crack. So that's one good solution. Another one is the airtight drywall approach. So this is using your drywall as your primary air barrier on the interior of your building. Really good way if you're a production builder and you want to get down to that ACH 3 or 4 or something like that, is simply to take some of the sill seal, which is just a foam gasket roll. It's really affordable. Roll that out along the top of your top plate from the inside, the bottom, and at the corners, so that you're creating a gasket, and that stops some of that air from coming up into the top plate there. So really affordable way to get those blower door numbers down. Certainly spray foam, you hear a lot about that, and we've noticed that when we have used spray foam, we do get some pretty good initial blower door numbers. I do worry about spray foam over the long term as your primary air barrier, because wood does move with seasons and with changes of relative humidity and stuff like that. So over time, that can cause some cracking and separation. I'm not completely convinced that this is a great long-term solution, but it does show some really great numbers when you initially install it. You also want to make sure that it's being installed correctly and you're not getting gaps in that foam, or it's not curing correctly. There can be some issues there, along with just the fact that you're encapsulating all this perfectly good wood in plastic. And it's also hard for retrofits. If you're ever in the future trying to add an electrical box when there's spray foam behind it, it's very difficult. And there's issues with the global warming potential of some of the propellants in this foam. So some of the downsides of spray foam. And lastly, there's Aero Barrier, which is an interesting, relatively new product, which what Aero Barrier is it's a sealant that gets aerosolized. So the team goes in, they set up these tripods with this aerosolizing machine, and they'll pump sealant into it. And while that's happening, you take a blower door and you pressurize the house. And that aerosolized sealant then gets forced out all of those gaps and cracks and holes in the envelope, and it slowly fills in those gaps. And it's really cool. You can actually set your target as low as you want. If you want to meet passive house, you can sit there and pressurize that house and watch that number go down until you get down to 0.6 ACH 50, and you can stop it there. So it's really cool for that. It's going to be a really good option for production builders, first-time builders, or if you're in Washington and you find that you're not meeting that 5 ACH, or in the future a lower number, call in Aero Barrier and they can come in and very quickly set this up and lower your blower door scores for you really nicely. So some good options here. But I'm going to talk about what I think is a better option, which I think is more resilient, and I think also arguably a fairly cost-effective way to do this, especially as you get used to using this. And so What it is using, these sheet goods and tapes to create an air barrier on the exterior of your wall. So we're using the sheathing. You can see on that left slide, the green sheathing is a zip system sheathing, which has an integrated WRB. That's our primary air barrier that's running on the outside of our sheathing. And then what we do is we rip some 12-inch strips of plywood or OSB, and we set that on the top plate. And then we tape that. You can see that black tape there is a Sega product. It's called Sega Fentrim. And we tape that to our WRB sheathing on the outside and tape that together. And then we do that prior to setting our trusses. And then we go ahead, once that's all done, set our trusses on top of that. And then on the photo on the right, you can see on the bottom side, we've taken some OSB and we attach that to the bottom of that bottom cord of the trusses. And then we tape that to that 12-inch rip along the perimeter. So what we're doing there is creating an air barrier up our sheathing it goes over the top plate, but under the trusses, and then connects to that plywood or OSB on the bottom cord of that truss, therefore creating a really robust air barrier right there. We find that when we do this, along with dealing with the air leakage at the bottom plate, which we'll get to, we're seeing blower door numbers come in on our first blower door of significantly less than passive house levels of air tightness. So I would say also that putting that 12-inch strip of plywood onto a typical house maybe adds an hour and a half or 2 hours of work to our team. So it's not a huge deal to do. It's just a different kind of order of operations. You want to make sure you do that prior to setting your trusses, because once those trusses are there, it gets really difficult to try to, origami your way around those trusses for the air barrier. This is just a representation, a detail of this exact same thing. So you can see that the sheathing is on the outside and that 12-inch rip kind of goes over that top plate and hangs into the interior of the building. The red dashed lines are tape that seals that up. And one thing to notice here is you can see that we're using a truss lock screw to hold our trusses onto our top plates of the walls right there. And we do that in lieu of the Simpson H25 connectors or the hurricane ties, because trying to tape obviously it wouldn't work if you had this sheet of sheet good right there. So use those, tell your engineer to spec those, truss lock screws. And ultimately we find that those go in much faster than the H25 or hurricane tie connectors anyways. So you can screw right through there. As long as you don't pull it out, you're not going to affect your air barrier at all. I made a note here too that you can actually create a service cavity below that air barrier just by hanging a 2x4 or 2x6 below that, which then also protects that air barrier from anyone trying to poke through it, any of your subs or future homeowners. It also gives you a service cavity for putting things like can lights or mechanicals in there too. This is the same detail, just smaller. I included it here so that when we send the slides out, that you can take a look at this and check it out. This is for a passive house project that we designed and built a couple of years back. So it's got some exterior insulation and the rain screen and stuff like that on there. You are free to take this and run with it. So another way to do a similar thing, instead of using plywood and OSB, because as we all know right now, especially those sheet goods are so expensive, instead of using them, to just use a membrane. So this is the detail here, but the next slide kind of shows it. So what we've done is we've framed our walls, and prior to setting our trusses, or in this case, rafters with nominal wood, we've just draped some of our WRB material over that top plate. And in this case, it's a self-adhered product called Sega My Vest SA500. And we drape that over the top of the top plate prior to setting our rafters. And then what we do simply is when we get around to installing the WRB on the outside is we leave that flap hanging from the membrane on the top plate. We tuck our WRB underneath it and then connect the two, and that creates a positive lap and a continuous air barrier all the way down the sides of the sheeting. So This is really quick to do. This particular product sells 18-inch rolls with a split back on it, so you can actually take off half of the backing and adhere the sticky part to the top of the top plate and keep the backing on so it flaps down below. So while you're finishing your roof and doing all this stuff, it doesn't get all gunked up, and later on you can tuck your WRB underneath there, peel off that backing and make that connection. On the interior, on the right photo, you can see that blue membrane, just a little bit of it kind of tucked over right there. And we've taped a membrane on the bottom side of our rafters here. And then we tape the membrane to that flap of WRB. In this case, it's a Sega Myrex. This is one of the smart vapor retarders, otherwise known as a variable vapor permeance membrane. It actually changes its permeability depending upon how much relative humidity it is experiencing. So it manages the amount of moisture that gets into the roof assembly, and also creates a really great air barrier. So over the top plate to the membrane, over the ridge, the other side of the house, and then back down. So really, again, great. We're seeing numbers lower than passive house air tightness with this particular strategy. Another way, if you take this a little bit further, is to do a foam-free vaulted and vented assembly. On this one, essentially, we've taken our rafters, done the WRB over the top plate, connected to the WRB down the sides of the walls, and then added a membrane. In this case, it's a Tyvek commercial wrap over the top of the rafters. And then we've put some 2x2s or 2x4s over the top of that to create a vent chamber. And so this creates then we fill that chamber with cellulose insulation. And so this creates a vented and foam-free, airtight, really high-performance roof assembly. I just wrote an article in Fine Home Building magazine, just came out. It's in the June issue, that's just out a couple days ago. So lots of information there if you're interested in reading that. It's available at Fine Home Building and finehomebuilding.com also. So once you deal with the top plate, giving you a couple options right there, we have to pay attention to the bottom plate and how we're dealing with the air leakage at the bottom plate. And what these pictures are showing is the bottom of that passive house that we started with. That zip system sheathing is simply getting taped to itself to create the air barrier. And at the bottom, we've got that same tape product, which is that Sega Fentrim. It's the black tape that you're seeing there. It's got an extra thick layer of this acrylic adhesive that can just adhere to concrete. It doesn't require any primers or anything special. You can really just roll that out onto the concrete and the sheathing. And be sure you do roll it, because it does require that pressure to really engage and stick. So it's really important to roll this stuff out. But that will connect to, in this case, a slab on grade foundation, and creates a really, really robust and tight air barrier. Again, to have one of our laborers go around the house and put on this tape and roll it out does not take long. And I think on this particular house, we were less than 0.2 ACH 50 with just these simple moves. So you can see how, once you get your exterior insulation on here, your rain screen, your siding, it's really well protected. It's going to be really hard for any client or anyone to really mess that up in the future. And it's just super resilient. This is a detail of it. You can see what we've done here is we've actually scooched our wall to the inside of the house. Typically, you'd see that mud plate kind of flush to the exterior of the stem wall, of the concrete stem wall. We actually scooch it in, which does two things. It helps cover the gap of the interior slab to stem wall connection, that foam there. And then what it also does is it lines up and puts in the same plane our sheathing with the exterior of that stem wall, so that it makes that taping really clean and flush right there. But it also allows us to continue our exterior insulation in the same plane without having to bump it out with that sheathing difference right there. So this is a photo of it right here. You can see that I'm showing that it's all in the same plane. One thing to note with this is that you definitely want to make sure that you're holding that sheathing up off of that concrete we give it about 3/8 of an inch or so. And we also include that sill seal right there, because we really don't want that wood to wick any moisture through capillary action from that concrete and create an issue. So if you're going to do this, make sure to keep that sheathing up a little bit and get that sill seal in there prior to taping it. This is the detail, again, that'll be available for you to check out. And go ahead and riff off of this and take it. And if your team can find a better, quicker way, or you get some insight or some good ideas from this, please just run with it and use it. We're going to talk about another way to deal with the air barrier at the bottom plate. This one essentially is a membrane. And what we do is we take a 20-inch strip of the vapor barrier that you're going to use underneath your concrete slab. Typically a 6 mil or greater polyethylene sheet. We tend to go with like a 10 mil just to make it extra durable. And you set that sheet over the stem wall prior to framing your walls. And that gets temporarily tacked up on the outside and the inside while you're finishing out your slab on the inside and you're doing your work on the outside framing. And ultimately that inside flap gets flapped down and taped to the vapor barrier that goes underneath your slab, which continues the air barrier underneath the slab and then under the bottom plate. On the outside, we use a self-adhered membrane, which is important with this detail. You could use a self-adhered or a liquid applied. I would not recommend doing a mechanically fastened WRB with this particular approach, but that flap will kind of come up the outside of that wall, and your WRB will lay over the top of that, and that connects it so that you've got an air barrier that travels, you know, the exterior sheathing plane under the mud sill and then into the bottom of the building. So this is some photos of what I'm talking about here. So on the left, you can see that we got the green polyethylene sheet is just set underneath the wall framing. In fact, on the bottom right, you can see where we got a wall ready to stand up, and we've draped that 20 inches of that sheet over the stem wall. You stand the wall up and you just kind of tag that up. On the top right, there's a picture of myself there showing the self-adhered membrane. That green polyethylene sheet gets stapled up top there. And then our self-adhered WRB gets adhered to it and lapped over it along with our kickout flashing. So any bulk water is just going to go right over the top of that, and it's going to get sealed from an air barrier perspective by that WRB. And so it creates that continuous air barrier underneath. And it's, again, it's a quick thing to do. Rolling out that 20-inch strip of polyethylene is not a big time-consuming task. You know, the WRB, tacking it up on the outside is not difficult. And same with the, you know, laying out your slab or whatever you're using. In this particular case, we have some gravel in here because we're doing a concrete-free floating plywood slab, but it's the same as if you were doing concrete, because what you do is you simply just put that flap down and connect it to the polyethylene sheet in the field, and you tape it and detail it. So again, this is a detail of that. This particular one here is the floating plywood slab that I was talking about. So we've got a gravel capillary break. We've got some insulation, which we're using a GPS rigid foam insulation. Then we've got that blue line you can see right there is the vapor barrier, the 10 mil polyethylene sheet. And then we floated 2 sheets of cross-laminated plywood, 3/4 inch tongue and groove plywood over that, which we then attach our finished floor to. So great air barrier detail, along with a way to avoid some of that embodied carbon in the concrete. So last thing, we definitely want to pay attention to testing as you go. Definitely, if you're a contractor out there, this is like not, you know, it's like a carpenter not having a hammer, in my opinion. If you own a construction company and you're building these buildings, you should own a blower door. I believe they're available for around $3,600. They're not inexpensive, but they're also the only way we can really test our buildings and make sure we're doing them at in delivering what we're talking about doing, in providing that comfort, that energy savings, that resilience, and just lowering the amount of energy that we're using in our buildings to kind of eat away at some of that orange slice of the pie that I talked about earlier. move on to this video right here, which if I recall, I could just click on this link and hopefully everyone will be able to see.
There it comes.
And so this will get set 2 layers deep here, and that's going to connect with our thermal boundary with the ICFs right here, therefore creating that continuous unbroken insulation up into the wall area. I always want to make sure that we've got a continuous thermal boundary along with that continuous air barrier. And then once we get this set, we're going to flap this back down here, come down over the top. And then we're going to then roll another sheet of this out into the field and then tape it all together. So that's going to create our continuous air barrier from the outside under the plate to here, get taped throughout the whole building, and then the same on the other side. So we're creating that perfectly continuous air barrier there. This is also our vapor barrier. So this is also keeping any incidental vapor and moisture from getting into the building, because this is vapor impermeable here, and this gets completely taped. Any penetrations for plumbing, radon, stuff like that will also get detailed and taped around there and make sure that we're keeping that vapor in the ground and not into our building. So once we get that all detailed right here, what we do is we're going to install 2 layers of 3/4 inch plywood that are going to be staggered seams, which is going to create a floating, subfloor essentially. And we're going to hold that back about 3/4 of an inch from the wall to allow that to expand and contract, because wood will move over time. And that'll simply get set here, staggered seams floating, and then we attach our finished flooring to the top of that. And so that way we're creating a really robust, airtight, vapor managed, fully thermally broken, concrete free foundation. Here we're going to talk about how we continue the air barrier at the top of the building, or at the top of our wall. So on the outside, we've got our WRB, and as you recall, we had put that 18-inch layer of WRB over the top of our top plate. So what we're looking at here is our top plate condition. And this blue piece right here is that flap that we've laid over the top right there. And what we've done is we've simply wrapped it over, adhered it to our bottom plate, and then taken our membrane right here, this is a Sega Myrex, and then connected it with the tapes to this membrane. And that continues our air barrier from the outside over the top plate to this interior membrane, which then travels across the building and connects to the other side. So that will connect our ceiling over the top plate, goes down the WRB, down the walls, and then goes through the bottom plate, under the bottom plate, to our vapor barrier on the foundation side. So that creates an unbroken, continuous air barrier all the way throughout the whole building.
So that I noticed in the Q&A, there's one question anyways while we're trying to sort this out.
Yeah.
There's from Nick, it says the issues I mentioned using spray foam, wood moving throughout the year, do you know if the aero barrier product would suffer from the same fate, that being cracks over time? Yeah, really good question. It is the same thing, right? I mean, the wood is going to be moving with the seasons, with changes in relative humidity and those kinds of things. And I don't see why it would be any different. The aero barrier is elastomeric, so it does move more than spray foam. Spray foam is a hard plastic, especially both the closed cell and the open cell spray foam. So it will have a little more flexibility. And I actually brought this question up to the folks at Aero Barrier, and they had an interesting response. If you're noticing after 20 years that your blower door numbers are slowly growing, and it's time to, seal it up again, call us up, we'll come in and we'll re-aero barrier your house for you, which, I thought was a fair point. It's a bunch of work to do that, but, if you can get 20 years and it lasts that long and your blower door starts creeping up by a little bit, it's probably not the end of the world, but good question. So we'll leave some of these other questions for later here, and I'll continue on some of the slides here. So, if you're interested in learning more, definitely check out the Sustainable Homes Professional course. This is something that I know I really enjoyed when I took it, probably about 6-7 years ago. here are some slides and some images of it. We've got some recorded content of myself and Bruce Sullivan from Base Zero down in Bend, and Stefan Aguier from Green Hammer. So there's these tours, webinars that we're doing right now. There's all the recorded recorded video content similar to the one that you just saw me talking about just now. And also all of the courses that you can take online. So you can do that at your own pace. So this, is an online format. It's created for the Pacific Northwest specifically, but I think it's got a lot of, I know we got people from all over the country and one person from Croatia. I'm not sure the climate zone there. But a lot of these principles and ideas can definitely be used in other places too. So we just launched this in March 2021, got some new content in here. We all of us instructors redid the curriculum and all that. We're pretty proud of it. You got 15 hours of content. Again, it's got those videos, the site visit tours, the webinars. There's guest speaker presentations. There's some product demonstrations from some of these high performance building products. They're coming on to talk about their offerings. You also get some continuing education credits, and you can get to earn the Sustainable Homes Professional designation. This is something that I sent all of our staff through. So it's a great way if you're a business owner and you're trying to get just the knowledge of your team up to snuff, especially now with this online format. It's much more accessible, and you can do it on your own time. And the price point's a little bit lower than the in-person courses. I highly recommend doing that. And I've noticed that when we've done this with our staff, that they start asking all the right questions. They really get behind it. They start to understand some of the hows behind the whys, and really get passionate about it. So highly recommend taking this course. John, I don't know if you can toggle to the next slide. There is a discount if anyone today would like to sign up for the Sustainable Homes Professional. It's $50 off. I believe the code on that, John, I think you've got it, is OTL 50, I think. John just put it in the chat. So if you're thinking of doing it, today is a good day to do it. There's other discounts available also if you visit the Earth Advantage website. So by the time you kind of patch those all together, it gets to be a pretty good deal to take this really important course.
So let's get on to the question and answer.
Sure. Let's see. So I do see them. So I'll just kind of say Benjamin Wilt says, what is your air sealing budget for tapes and barriers outside the rain screen on a typical home? It depends. It's a slippery answer, but I think that on average we're seeing maybe a premium of 3 to 5% for going these levels of air tightness. And when you translate that into dollar terms, it's about 0.3 to 0.5%. So when you translate that into dollar terms, it's really not that big a deal when you think about the benefits that you're getting for all this. I'm trying to think our last home, if you include all of the, the SIGA membranes and tapes and some of these really high performance things, I want to say it was for a 2,500 square foot home, it was additional $5 or $6 grand. So, it is not nothing. Tyvek is cheaper, but again, I would point back to you will save that money over time with less maintenance, certainly better indoor air quality and health, comfort, and all that stuff. And if you're taking this course, my hunch is that you're trying to build better buildings for your clients and yourselves too anyway. So there was a question, about if I'm familiar with Knauf EcoSeal. Not really. I know of it. I haven't used it personally, so I don't feel like I can really address that directly. Let's see, Jürgen asked, nice to hear from you, Jürgen. I haven't seen you in a while. What are you using to protect exterior rigid insulation from the top of the foundation wall going down a grade? So yeah, good question. So when you've got your stem wall and you've got this exterior insulation, you can't just leave that exterior insulation open to the elements because it will get degraded by ultraviolet light. It can get kicked and dinged. Landscapers can come in. You know, rodents and vermin can chew at it, all that stuff. So you got to protect it with something. We've done a bunch of different things. There's this kind of cheap vinyl roll that has an imprint that looks like concrete, or it's supposed to look like concrete. It's like an FRP material that you can roll out and put on there. It's durable because it's made out of vinyl. Not the best looking. It's affordable, but it works. There's that. We've done some of these new. I don't remember the name of the product, but it's basically a fly ash and composite board that doesn't wick. You want to make sure you're not putting something on there that's going to wick water or degrade. One of the issues with putting like a cement board or something on the outside is that cement board is it's got a really strong capillary action, and it can really wick a lot of moisture up. So we try to avoid using the cement board stuff. There's certainly metal that you can use. Stainless steel we've been using a lot of lately, just because it's super durable. It looks good. You know, you can get a 10-inch, 12-inch sheet of it. It is expensive, but for a custom home, that premium's not really a huge deal. If it's a spec home or something like that, I can't imagine that stainless steel would be in your budget. But yeah, those are some of the things that we've been using. Let's see, Joshua asked, it's moving here. Any thoughts about the pros or cons of using OSB versus a smart membrane for the air barrier at the roof or ceiling plane? Yeah, so the smart membranes essentially are going to open up more the drier it gets, and they're going to close down more the wetter it gets. Whereas OSB, it does that a little bit, but not nearly to the amount that these smart membranes do. So the idea is that, you know, in wintertime, when you're trying to keep that moisture from getting into your roof assembly, that's when it's most dangerous because it's cold outside, and this cold sheathing can cause condensation issues. So as you know, it gets more moist in here, these things are closing down and preventing all that moisture from getting into that during those critical times of year when that sheathing is the coldest. Now in the summer, when the opposite's happening, when it's not cold outside, we're not worried about condensation, that membrane will open up and allow for more drying. And so if, you know, alternatively, as it's opened up more moisture can get in, but we're also not as worried about it because it's the middle of summer. We're not going to get condensation when it's 80 degrees or actually much hotter up on your roof. So OSB doesn't offer those properties. So I would say that it's more resilient to use one of the smart membranes if you can pull it off. And nowadays, honestly, with the cost of OSB, it's probably more cost effective anyways. So let's see, another question about how long you've been using these methods. Are we running into any moisture concerns at the junctions over time? We first started using these back in 2012. So we're getting on almost 10 years of doing this. And we have not seen any issues. In fact, some of those first early homes that we did with these methods, we actually embedded some sensors, so temperature, relative humidity sensors in the critical parts on the inside of the sheathing to measure how it's doing. And we have not seen, it's just been mostly drying out over time. We have not seen any moisture spikes or anything like that. You know, if you're making an airtight envelope and you're separating that envelope from its exterior environment, that's the best thing you can do when it comes to managing moisture. And then if you're including a ventilation system with continuous balanced heat recovered ventilation, that's also going to help manage that moisture. So there's belt and suspenders ways of doing this. Additionally, if you can use cellulose insulation or a hydrophilic insulation, it can act as a buffer over time for those moisture swings during seasons or during some particular event where you might have high relative humidity. But yeah, we have yet to see any issues, and just talking to other builders that have been doing this longer than I have, especially once you get over to Europe, where they've been doing it longer than here in North America. As long as you've got an airtight barrier and you're including that balanced ventilation and you're kind of using a lot of these strategies, making sure that you can dry in both directions, you're not creating vapor sandwiches or trapping vapor in any way, really not seeing any issues. Arguably, you see a lot more issues with homes that aren't done to this level. We have had to do some major renovations of some houses that were less than 10 years old that were having major moisture issues and rot and failure. And they were using some high performance products. But the problem was kind of the 101 basics. There was, mislapped WRBs. There was bad window detailing. There was no overhangs and roofs. There's usually a reason why. It all goes back to the basics. Even if you're using these really great materials, you still have to install them correctly, and you'll run into issues if you don't. And that happens if it's a high performance house or a regular house. So let's see. How does this relate if I plan to build all exterior walls with ICF? Well, concrete is a great air barrier. So, that's a fairly resilient wall. Where with ICFs, where you're going to have your biggest problem is going to be at the top plate where your roofing members are kind of hitting the top of that ICF wall. So again, there I would recommend using a membrane, draping it over the top, or prior to setting your rafters or your trusses or whatever you're using. You could also use that plywood or something like that. Although in this case, probably a self-adhered membrane would be my recommendation with the ICFs. And then continue that air barrier on the bottom side of the of those rafters or trusses, whatever you're using. And again, it's the usual stuff. Seal your penetrations for your MEP. Pay attention to your windows and doors. So let's see. We've got another question about: have we tested ACH on our homes years later to see the degradation and effectiveness? No, honestly. It is, I have had some other builder colleagues do this, and they tend to see that they go up a little, but not a lot. A lot of this has to do with human behavior, I suppose. If your clients are, calling in the Comcast guy constantly and drilling holes through the walls, or, affecting that air barrier. But again, with the exterior air barrier, if you've got exterior insulation and siding and a rain screen, and then the interior, you got your framing and insulation and your interior finishes, it's so protected, that assembly, that it's highly robust, much more so than doing an interior air barrier approach like with the drywall. So we do have some houses that we've gotten some really great relationships going with our clients, and may this question be a good reason for me to get out there and retest it so I can answer this question better next time. So we've got one here from Sam. In a vented roof assembly where you have that smart membrane on the warm side, how do you approach penetrations from recessed lighting, etc.? Good question. There's a couple ways you can do it. If you're using that smart membrane, they do require the manufacturers require that you actually strap 2x material perpendicular to the bottom of the rafters or trusses after you install it. And that's meant to be able to hold it in place while it's being filled full of insulation. So what we do is we just take that 2x4, that 1.5 inch gap, and then we use for lights and electrical and stuff like that, we use shallow boxes. So, they're less than 1.5 inches. And then we can use those for our junction boxes in that interstitial space between the drywall and the air barrier. And you can run your electrical through there and those kinds of things. You could also build a dedicated service cavity. So instead of the 2x4s, you could just turn them, perpendicular. And then you've got 3.5 inches of space that you could put things in there too. So yeah, it's a good point. You definitely do not want to punch that air barrier. If you didn't have a choice for whatever reason, I would recommend using an airtight electrical box. There's some really great ones called airfoil, where the wires go into the box and it's got like a double walled assembly so that you can then take some sealant in that in between those two walls, and it seals up the wires that go into the box. And they're also fairly shallow, so you're not going to displace insulation and things like that. But generally speaking, if you can all the way back at design, just never design penetrations into the top story of your buildings in the first place. That's a great idea. If your clients or your program really needs that, create some sort of service cavity so that you can, get those things in there. Let's see, John, am I missing some questions here?
I think you've gotten through all of them. If anybody else has been waiting to type their question in, now would be the time. Otherwise, we'll go ahead and sign off. So any parting thoughts you want to leave the crowd with, Josh?
Give this stuff a try. I mean, the first home or two we built with this, there's definitely a learning curve. But it was fun. And, now that we've been doing it for over a decade, it's just become building. It's not really any different. And there's not really that much of a premium to it. And it just becomes part of what you do. Our team, if we're not doing this, it feels very strange to them. So I recommend just, do it, get over that learning curve, pay attention to addressing these things very early on in the design stage too. If you can design the stuff in early on, that really makes a big difference. So with that, thanks everybody for joining us. You're always welcome to give me an email, josh@birdsmouthpdx.com. And please check out the Sustainable Homes Professional course. I mean, it's an awesome course, one of the best ones that I've come across. I'm super honored to be a part of it and actually be teaching it right now. I highly recommend checking that out.
Thank you very much, Josh. This has been a fantastic webinar. We really appreciate your time in putting together and in sharing all your details with everybody. I'm sure that'll be a valuable resource for those who are looking to make some design changes. And thank you for everybody for joining and spending the time with us today. And we hope to see you in the next 2 Fridays for the other 2 On the Level webinar series. So have a great rest of your afternoon and a great weekend.
Thanks, everybody.